Good morning, everyone, and happy Friday. It's, I think, the 6th episode of HeleCloud Talks
It
Cloud
is.
with Walter and Lina, and we have two really interesting guests today that are going to tell you stuff that you probably didn't know, or I don't know in any case, about the telco industry. I'll let Chris present himself, and then Nikos can go right ahead because Nikos is a colleague, so you go first, Chris.
Well, I've spent 40 years in telecommunications and technology, right from graduating with a computer science degree in the early 80s. Research and development for the first 15 years of my life. The second 10 years of my life, I was the chief technology officer at Vodafone, another fixed line carrier in the UK called this, and eventually the managing director of research and motion for Europe, Middle East, and Africa. Then the third and final chapter of my career that I'm living in now is I started my own private equity fund, and I've been investing in startups and co-founding technology companies, largely in the telecom space, but grossly across anything in technology. And had the benefit of a couple of very large successful exits this year to Microsoft and F5. So it's been a good year.
Nice.
Already, and it's just February. Chris is actually one of our HeleCloud cloud ambassadors, and because of his strong background in telecommunications, we looked for someone to kind of complement that background. And then this week I was talking to Nikos. We talk to each other pretty much every day. And I was talking to Nikos, and I mentioned Chris and his background in telco, and he said, "Oh, I actually have 20 years of background in telco." So I said, "Okay, great. You are now volunteered for coming onto the show on Friday." Nikos, maybe you want to talk a little bit about your experience in telco and cloud and that ecosystem.
So like Chris, I finished my master's in computer science after the BSc in the middle 80s, 87. I've been in the industry since 1990, even though the 2 years in the Greek army were kind of counting as experience because I was doing computer-related things rather than army-related
Espionage.
things. Yeah, exactly. I wish. I've been in the telecoms industry since '98 when I joined Capgemini, where I was dispatched down to Singapore to set up StarHub with 5 other lead consultants and spent a couple of years there. That was my first introduction to telecoms, and then I stayed since then with Capgemini twice. IBM Global Services was running the telecoms vertical on the Sibel CRM practice. So CRM has been another of my pet hobbies in business, and then sometime with Genesis Telecommunications, where I was running part of their pre-sales delivery, and I ended up with running the Tech Mahindra business consulting on the telecoms vertical. I was the VP for telecoms in iGate before the takeover by Capgemini, and because I was kind of dabbling with the cloud and kind of considering how telecoms could actually start adopting the cloud for the last 5-6 years, when I was especially near the end of my last tenure with Capgemini, I met Dob, and I ended up working and having lots of fun here at HeleCloud for the last 4 years. Yes, and I started running the consulting team here, and I'm now running the whole of the delivery. And as I said, having lots of fun trying to convince people of the benefits of the cloud. In fact, I don't think they need much convincing these days. It's
but I think that telco is an industry that we haven't danced with, at least at HeleCloud. So I did a lot of reading this week, and which is also for me personally one of the benefits of this show is that I get to explore parts of the industry that I'm not that familiar with. And so, Chris, you mentioned when we did the briefing call that there's quite a large move that is actually underway towards public cloud, and that there's huge technical depth in the traditional telco industry. Can you tell us a little bit about what you see there?
Yeah, so quite clearly everybody is driving cost reduction, and they have to drive service flexibility. And ultimately, architecturally, over the course of time, that will result in cloud-centric architectures. In the meantime, what you do typically is go through a series of steps where you try to commoditize the hardware, you try to virtualize your software, you try to centralize the running of your software, simplify the amount of software services, containerize them, and then where you place them is subject to, some aspect of the application, some aspect of regulation and things of that sort. I guess in telco, some of the things that a lot of people don't realize, and they particularly cited around the over-the-tops that come in and enjoy huge success in telco-type applications like WhatsApp. But it's really not a level playing field, because if you're a telecoms company, you're regulated by the nation. You have to comply to a set of standards and a set of laws that exceed anything that helps or facilitates your business, and you still have to be compliant. Every phone call you have to provide legal input for government services. You have to supply billing records, even though they're not billing records, they're usage records for the use of somebody in government to chase them up. You may have to have all of your personal information data stored only in one geography and not allowed to cross borders. So there's an awful lot of constraints and restrictions. That, coupled with the fact that telco is already enormous. I don't know how many billion messages a day are being sent now in any large developed country. I don't know how many billion calls are made, but it's an alarming machine, giant machine that's already working at a very high capacity. So to develop and evolve that into a superior architecture or a superior cost base is a non-trivial exercise.
Yeah. I mean, this is the thing, right? It's like trying to change the wheels on a Formula One car while it's driving 200 kilometers an hour, and I think that those are, for me at least, some of the most interesting problems in technology. How to do that while not disrupting service and still ending up in a better place in the long run. And I guess the other thing I was reading about is that. Specifically when it comes to virtualizing a lot of these workloads to a public cloud environment is the part where you have to interface with the physical equipment for things like usage metering and billing and all of that stuff. That seems to be one of the parts where it's quite tricky to make these things work together, because you're on the side, you have the physical equipment that isn't necessarily set up to deal with a cloud, and then you have a cloud environment where you want to do everything agile and scalable and all of that stuff, and that seems to be quite a challenge as well.
Yeah, I remember when I was at.
Go ahead, Nikos.
I was just going to say, I remember the time I spent 4 years as the products director for Tiscali and then product operations director for TokTok. After the takeover, one of the biggest problems we had with Tiscali was that we couldn't actually monetize IP as well. We didn't have the equipment to measure IP, and in fact, in TokTok, they gave IP for free because they could monetize and they could measure voice, right? And they were making the money out of the voice, and they were giving the IP for free. And telecoms always struggled because they came from a connection-based background of charging for IP. The systems that we used were very slow to adapt in charging IP, and that's why you see charging in IP being a little bit of a black art at the moment. Still is, because there's a lot of legacy systems that have not been changed yet.
Well, there's another aspect. It's the type of IP. A lot of telco IP has to be done in real-time protocols. Managing a real-time protocol is very different than just managing any IP. Real-time phone conversations, you have to be real-time. Real-time billing and rating, that has to be real-time, not near real-time. Messaging can be near real-time. Some things can be batch-oriented. Emails can be batch-oriented. Browsing, near real-time. The real-time sensitivity of a communication service provider creates an entire wealth of complexity.
Yeah, that's true, and then and that doesn't even take into account that we're about to run into the 5G era, which I think is there's quite a lot of hype about it. But if you look at the actual technology and the possibilities that it's going to unlock, it's quite interesting what kind of an effect that will have on the load on these networks. Do you have any experience? Because I saw that there was like something like 80 5G networks developed or deployed globally by now, just by Ericsson. So this stuff is gaining steam, and I see Amazon offering 5G services as well. What's your take on that? Basically new stream.
First and foremost, somebody announcing the availability of 5G is typically on a geographically constrained environment and is typically a marketing exercise and not a real business exercise. I don't know how much revenue is produced, which is unique to 5G over the next 18 months. I would suggest to you an insignificant of revenue attributable only to 5G products and services will be available. And the carriers are also learning about 5G and what its use is. And some of the carriers are saying that the real killer use case for 5G is a total cost reduction. The fact that they can have so much more traffic over the same amount of bandwidth in the air, the concentration and the architecture means that they can reduce the cost and possibly get 3G out of their networks, reduce the cost of that. But the other interesting phenomena about it, and I was just on a session with a bunch of the CTOs last week, they said the biggest thing that isn't known about 5G is it's not as much a technology exercise as it is a civil engineering exercise, because the antenna systems are so massive and you need to support so many generations of wireless protocols that actually a lot of the complexity is just in the civil engineering rollout of 5G. And it's not something that you immediately go with, it's almost too boring. 5G is supposed to be all, ooh, isn't this cool? It's super high fast and it enables immediate gaming and super cool stuff. Not, shit, I need another freaking crane.
Where am I going to put my antenna? Yeah, no, I think that's valid, and that's probably the part that most people don't think about too much. And I think what you're saying is also my feeling that 5G is currently sitting somewhere at the top of the hype curve, and the actual business revenue that we're seeing is negligible. You see Amazon promoting their 5G services, the start of their portfolio on the global reInvent conference the last 2 years. That 2 years ago it was a very little bit. This year it was a little bit more, and that usually means that as you say, it's a marketing exercise. They're initially telling us what they want the world to look like, and then they look at what the market actually does and implements, and then from there they iterate on to see where we end up with a useful set of services. And so I think that will take 3 to 5 years would be my estimation before that becomes a serious part.
Yeah, for sure. It's a technology.
It's always, because there's so many incredibly smart people that set the standards and the specifications, there's a giant overlap in technology. Like right now you can talk about speed and latency being a unique feature to 5G, but it isn't. It's precedent upon some 4G technologies that if you did upgrade all of your systems to the latest 4G technologies, you would enjoy the similar speed and latency. So there is also this kind of, the unique bit is oversimplified and it's not the way it's going to work out. Sorry.
Interesting.
Yeah, for certainly a technology that is looking for products and answers at the moment. I remember when I started looking at 5G, the interesting thing was that the business model was not actually from the services that telcos were going to supply, but of the connectivity it gives to industries that could really use it, such as connected cars, connected planes, etc. And I have a feeling that in the longer run, the usage of the service will be dictated by those industries, not by the way the telecoms have deployed the service. And there will be other players coming in.
With respect to the Internet of Things, if you take a look at all the things that could possibly be connected that need to talk to other things, the Internet of Things could comfortably overrun the amount of phone-connected type terminal devices. But a lot of those connected things wouldn't benefit from a 5G or a 4G. A lot of them are quite chirpy in the nature, low bandwidth type applications. And that isn't really a perfect fit for 5G, 4G type of services. Now, having said that, there is something called narrowband IoT that fits above some of these technologies, where with some suppliers you can use the same antenna systems and much of the same hardware. Now that works out because, again, it's about a lot of connections, but very little bandwidth to each connection, and super, super, super cheap devices, and super, super, super good battery life on devices.
Yeah, the power consumption. This is where LoRaWAN comes in, right?
LoRa, Sigfox, and narrowband IoT appear to be the three dominant options in that space.
Chris, I remember, again, when I started dabbling with 5G as a protocol 2-3 years ago, one of the things that I was reading, and it kind of always made me wonder how telecoms are going to cope with it, is that especially in the cities, you need a lot of small stations to make 5G work, given the density of buildings in large cities. You spoke about the engineering concerns earlier on. How do you see telecoms responding to that and making 5G properly available in the cities, cities like London and even worse, the big cities in Europe? I mean, exactly. But I can think of Athens, like big tall buildings, cement everywhere. A nightmare to deploy 5G, right?
So you're absolutely spot on. And a good friend of mine came to me about 5 years ago, and we looked at this problem and said, you know what? You can't engineer dense urban environments from the outside in, from macro cell in, because it's a constantly changing equation. As building standards improve, windows, coverings, the restriction of radio frequency transmission, egress into these buildings or ingress into these buildings make it impossible for macro cell traditional rollouts to really service it. So we came up with a company that does building coverage from the inside out, and we have neutral hosts in a variety of buildings paid for by the building owners that allow for roaming in and roaming out to any telco vendor that wants to subscribe to the service. That business is a material business. And the fact is that the operators still have their head around how do they do service across.
Sorry, Chris. You're breaking up. Ironically, talking about the
connectivity. Actually, for viewers, Chris had a power outage at his home literally 5 minutes before the call, and it's been recovering since that. But that's why the connection is spotty. But
did you get any about this in-building stuff?
Yeah,
we got the beginning.
We lost you near the end, Chris, I think. The last couple of sentences.
The long and the short of it is you're going to have to start doing more capacity planning from inside out. Lena, you're also right, where there has been a dramatic shift in footprint of radio frequency usage from being dense urban-centric between office hours to being suburban and rural-centric in office hours. Mm-hmm. That in itself presents giant engineering challenges to everybody.
Yeah, I was also a member of a big team of infrastructure provider, dark fiber, quite a few years back, and the biggest problem that the government was trying to solve with that bid was the availability of broadband, be it wired or wireless, in places like North Wales, for example, where it's notorious for black spots, right? So how do you cover rural communities where the economics don't work really? And we had the same problem when I went down to New Zealand to help Telecom New Zealand deploy next generation services. The population density wasn't, it didn't make the business case work. And it was a case of either the government we have invested, and then how do you, make sure that does not become a monopoly. But it had to be government supported rollouts.
Yeah, there is some privately funded rollouts of fiber infrastructure going on in patchy areas around the United Kingdom. And those assets, when you roll out fiber to a town or a city, is turning into a strategic asset to be acquired. And there are people saying, that's an asset that keeps on giving over the course of the next 10, 20 years, and therefore this is the value of it. So that is happening. But the bigger phenomena is you can now, the licensed operators can now let a third party use their frequency in rural environments. And if there's an economy in it for a third party to roll out a radio network, and create a relationship with Vodafone, they can roll out a radio network using licensed spectrum from a carrier.
Yeah. The other interesting thing, of course, in this equation, it's not only the hardware, but also the software. So the other thing I was looking at when I was looking at 5G was a lot of the discussions at that time, and unfortunately I've lost very close contact with the industry for the last 4 years, but at that time, the other question was, how quickly will telcos adopt software-defined networking and to an extent public cloud services to make 5G work? Because obviously 5G is all about dynamic reconfiguration of assets, of the hardware assets with using software, and SDN was the solution for that. So what's your view on that? Do you think that telcos have moved in that respect?
Not sufficiently is my answer. I think it differs dramatically by carrier and by geography, but I don't think they are anywhere near in realizing that vision. But having said that, that giant shift, around a dense urban area like London, when the lockdown happens, it's quite a dramatic shift in usage patterns. Vodafone and the other carriers were able to reconfigure their networks adequately, that there was a reasonable amount of coverage and capacity pushed out to the edges of the networks or out into suburban and rural environments to make this not a disaster. I wouldn't have said it was perfect, but it certainly wasn't a disaster. So they do have still some speed without fully adopting automated, sophisticated SDN type networks.
Yeah, a little bit of an anecdotal thing, but I remember I was talking to a telecom a couple of years ago, 3 years ago, because they were advertising, public cloud provision, and we, blah, blah, blah. And when I spoke to them, it was all smoke and mirrors, I'm afraid. They were, so I remain anonymous as a telecoms, but I have seen that. Telecoms have done it, have survived, but my view is that there's still a lot of room of improvement in that area, as you said.
Nikos, when I was doing the research for this call, I started looking into telcos and public cloud, and all the names that come up are all the old school suspects, right? So you're looking at all of a sudden VMware, IBM, those players, Amdocs. They're relatively old school players that are also trying in their own right mind, trying to adapt to this new thing, and then trying to deliver services to customers that are requiring a new thing. That's a second level abstraction of next generation thinking. And I think that what I see, at least, is that when I look at places like Southeast Asia, because they have less of the legacy stuff, they have an ability to move much faster. When I was living in Malaysia in 2008, 2009, they had faster data transfer, wireless data transfer there than we had here in the Netherlands, and it was much cheaper, simply because they didn't have copper cables in the ground like we have here, and so they didn't have any of that legacy. So they rolled it out much faster, and I think that's quite a interesting part of the of this movement. That there seems to be a bit of a recycle of players going on.
There is to a large extent. They've got the footprint, they've got the relationships, and they understand the full requirement set. So in that, they have an advantage. Their disadvantage is their horrible temptation to take legacy software and try to migrate it to the cloud and attempt to containerize it and adapt it architecturally. And that never will work as well as somebody that grows up in the cloud, that's a cloud native design. And, so those will overcome in due course. But the requirement set are so wide, diverse, and complex.
Yeah.
They gotta roll for the time being.
Yeah, Chris, I think you hit the nail on the head there. My specialization was with telecoms was deployment of BSS solutions. I mean, I was at the software layer, not much at the hardware. And the biggest problems that the telecoms of today's have are that they have lost the big revenue streams. Telecoms, because they came from a monopoly position of the past, were used to very comfortable living, as you probably know, right? Monopolies that were making as money as they could, as they could charge out. Good old days, exactly. So they became fat and accustomed, and also people sold to them solutions that were expensive and big, right? Talk about the non-vendors. I won't name names, but there was a lot of legacy deployed, especially when privatization happened and new services came up through the adoption of digital, etc. So the problem they have at the moment is that revenue has gone away. They are competing in a different world, yet they are left with a lot of legacy software. They have been left with a lot of regulation that is monitoring what they do, as you said in the beginning. And in my view as well, what is not helping them is the fact that a lot of the traditional software vendors have been acquired, or they are themselves in trouble because they are not making the money out of the telcos they used to make. So I don't see at the moment, with a very few exceptions, any innovation in the BSS space coming up with products that based on microservices, on cloud native adoption of deployment that will actually address the needs of a telecoms. Because if you think about it, the Amdocs and the Sybils with a telecom vertical Sybil version and all these companies took many years to produce their software, right? And they spoke to large telcos. They had spent a lot of R&D money. I don't see that these days. I haven't heard of any company in that space that is saying, look, I'm coming with a new cloud native architecture based on microservices that you can switch on the service you need for what you need, because there's also a plethora of hardware and software combinations that you put in place to give the service that you need, right?
I think it's a trickle down effect, right? So new deployment ways and public cloud were invented. What is it? In the last decade, let's go with that. And then software developers started doing that, started adopting these new ways of doing it. Then enterprises started adopting these new ways of doing things. And then these kind of systems that are built by these large enterprises, they have a lot riding on it, and large customer bases, large revenue. So to move that towards a cloud native style deployment is really a long-term exercise, and I see that happening, but it's slow, and we're talking decades slow. So I easily see that happening over the next decade or so.
I'll put a real timeline on this, Walter. So we started Affirmed Networks about 10 years ago. Affirmed Networks decided to attack the enhanced packet core, the routing, all the data movements in a core network, particularly mobile-centric, but applicable to a variety of others. And we went fully virtualized day one, cloud native design day one. At the beginning, we couldn't use total COTS hardware. We had to have some specialization, but within about 3-4 years, we could use total off-the-shelf hardware. So we created that business, and we've done very, very well. Now it's a long race, and it's very expensive to do all the research and development in such a program. And we sold that company to Microsoft not very long ago, because companies like Microsoft are trying to assemble telco in the cloud type products and services. So we did that. We did that for Enhanced Packet Core, and it delivers today, and it's really quite amazing. But you're right around OSSs and BSSs. There's such a diversity of requirement, it's really hard to have any monolithic software address it all. So you might find little slices of it end up in the hands of venture capital backing and driven that way, and then assembled and integrated over the course of time. I suspect that's the model.
Yeah, absolutely. And it was forced. It was forced.
Sorry, Nikos.
Sorry, yeah.
We've reached our time, so I'll give you a final statement, both of you, and then we'll close off. Go ahead, Nikos. You can go first.
I will let the guest go first, please.
Yeah.
So the fact is, no matter what we think we're doing today, something exciting and new is going to happen that affects the ultimate outcome tomorrow. So the companies that succeed are the companies that are dynamic and understand that the world's in perpetual change, and pay attention, because you're going to have to pivot again very, very soon. That's it.
Yeah, thank you. And that applies to literally any business at the moment. If you're not part of the change, you're going to be in trouble. Nikos?
Yes, I think that the future is with companies that, as Chris said, are going to adopt the cloud and use the cloud to their benefit, especially in telecoms. Telecoms is lagging, and they are in a hard place. So, finding the right models to adopt the cloud and provide services to the customers, as well as use it internally for their benefit to cut their costs and come up with new innovation, new products faster, is going to be key for survival. And the ones that will do that are the ones that are going to survive long term.
Agreed.
Thank you. It has been a very interesting episode, because I have said absolutely nothing since the beginning, and it was amazing to just listen to this and learn. You really have a lot you can teach me, both of you, Chris and Nikos. Thank you very much for being with us, and I'm sure it has been an educational experience for our viewers as well.
Thank you. Bye-bye.
Yes, awesome. Thanks, Chris. Thanks, Nikos.
Bye.
Bye.
Hello, everyone.